One thing I like to remind you guys of whenever doing arc sine, arc cosine, and arc tangent is one that arc sine is the same as sine to the -1. These are the same right here and right here. They're exactly the same. Okay, they're written two different ways, and that's because arc sine was first, and then sine to the -1 came. We don't like to the -1 very much because that looks like a power. It doesn't look like an inverse, but it is a common way that some mathematicians, depending on which branch of mathematics they were studying, that's how they were using it a lot. And so we show you guys both ways. And here's the other thing. Sine. You guys remember what you used to plug into sine? Theta. This is an angle. And what would it give you as an answer? Yeah, what would you call that? Opposite over hypotenuse. What would you call that? Ooh, a ratio. Yes, I like that. But I'm just going to use a dumber word. I'm going to say sides. Okay, so those are sides, and those are angles. Okay, so what about arc sine or sine inverse? What do I plug into arc sine? You plug in sides, because the x's and the y's, they switch. Remember? Remember? We were just talking about this. So this is sides. And then this would be angle. Your answer is going to be an angle. So now your answer is radians. And so you're thinking backwards. So when you look at this and you're using your unit circle, what is that on my unit circle? It's the y values. Ooh, the y values. So what is this answer going to be? Here, let me draw my little circle right here to help you guys visualize. And some of you guys are taking out unit circles. That's awesome. Where are the y values that equal -1/2? There's two. There's one right here, and there's one right here. This one has a -1/2 for the y, and this one has a -1/2 for the y. Do you guys remember what this angle is? What is it? It is 7 pi over 6. And what's the one that goes all the way right here?
11 pi.
Yes, this one's 11 pi over 6. And so you might be thinking, all right, 7 pi over 6 and 11 pi over 6. There's two answers here. But I'm so sorry, guys. Both of these are wrong. Now, we found it right, but we totally forgot. What is the domain and the range for arc sine? So for arc sine, what's my domain? Ooh. And for arc sine, what's my range? My domain was -1 to +1. And my range, the only answers I can get are between -π/2 and +π/2. And we just went over in detail why this is true. But now since we know these two facts right here, now we can look at this and say, oh yeah, both of those are not in this range. Our range, -π/2 to +2, is only going to be angles in the first and the fourth quadrant. So this is probably the closest thing to our correct answer. But we shouldn't be going positive. We should be going negative. What is the distance from here to here? Oh, 30 degrees. But in radians, it is pi over 6. Negative. That's your answer. Your answer is -pi over 6. Yes. Does that make a lot of sense to you guys?
Yes.
Is it because you're starting from the bottom going upward?
Yes. Remember when we graphed the arc sine, it looked like this?
Mm-hmm.
All right? And what was the shortest y or x value right here? -π/2. That's the angle down here. And then the biggest is +π/2. And we go all the way up to, oops, I messed that up. That's supposed to be -1. And this one's supposed to be +1. And the highest it goes is +π/2. And the lowest it goes is -π/2. Wow. I almost messed that up. Okay, so because on this, the y-axis is our angle, and the x-axis, those are our sides. So, what about the next one? Where is sine equal to rad 3 over 2? Think of sine, so that's the y value. Where is the y value positive rad 3 over 2? And remember, we're only in this quadrant and this quadrant. Yep, this one's pi over 3. Is it pi over 3? Yep, pi over 3. Oh. Okay, what about our last one? What is sine inverse of 2? Now before, we noticed how our range restricted what our answer was for this top one. Look at that. We're plugging a 2 in. Wait a second. What's my domain for arcsine?
Doesn't work.
Yep, doesn't work.
So there's just not.
No solution.